Here the products manufactured by a company are defective. In a sample of 20 we got 2 defective items. First of all, we need to decide what is a suitable probability distribution for function. In this case, the question is whether it is a defective or non-defective product. The samples are selected, and we are interested in how many probability of defective or non-defective. So this is something like a yes or no type. It is either defective or non-defective. So the output here only two outputs. It's like yes or no type. So binomial distribution is suitable in this case. Now coming to the data given, out of 20, 2 is defective. Out of 20 products selected, 2 is defective. Observe, probability p-value is not given, and this is a mean number of zones. So they mentioned mean number of defectives in a 20 samples, it is 2. So what we can write in this case, first of all, what is the given data? If you see given data, mean value is equals to 2, n is equals to 20, p how do you calculate now, and q how do you calculate now? That we have to see. Now we know the mean value of binomial distribution. We know mean of binomial distribution expression, mean of binomial distribution. We already discussed what is a mean formula for binomial distribution. Mean formula is n into p, number of samples into probability of one success, np. Now in this case, n is given as 20 and the mean value is given as 2. So accordingly, this becomes 2 is equals to 5 minutes. So mean value is np, mean formula is np, and the value is given as 2. So what we can do, mean is given as 2, and by the formula np is the mean of binomial distribution. So np is equals to 2. N value is given as 20. 20p is equals to 2, which implies p is equals to 2 by 20, 1 by 10, 0.1. Once you get p, the q is nothing but 1 minus p. So in that case, 1 minus 0.1, which is 0.9. Now we have to calculate at least 3 defectives, probability for at least 3 defectives. Then for 1000 samples we can multiply with that corresponding probability. Here this 1000 is not the n value. Out of 20, 2 is the defective, so the probability of the defectives p value is calculated based on 20 into, not based on the 1000. That is later on calculation. Okay, so first, for at least 3 defectives, what is the question in this case? At least 3. What do you mean by at least 3 defective? At least 3 defectives. At least means 3 or more than 3. This is what the meaning of at least 3. That means you are supposed to calculate x equals to 3 or more than 3. That means x greater than or equals to 3. So we are expecting probability of x greater than or equals to 3. And the maximum value we have 20. So when you x greater than or equals to 3, when you write it in that form, it comes as probability of x greater than or equals to 3, which is probability of x is equals to 3, x is equals to 4. We have total 20 such samples now, so we'll get up to probability of x is equals to 20. But calculating this by binomial model from x is equals to 3 to x is equals to 20 will be a little bit lengthy, so we'll use alternative complement form. Alternative form for this in complement form, that is p of x greater than or equals to 3 can be written as If it is greater than 3, 1 minus you remove whatever less than 3. X is equals to 0 plus p of x is equals to 1 plus p of x is equals to 2, strictly x less than 3. So 1 minus these probability totals will be evaluated in this case. Let us see what it will be in a complement form. So probability of x greater than or equals to 3, 1 minus p of x is equals to 0. That means 20c0 into 0.1 power 0, q value is 0.9 power 20 minus 0, plus second one 20, so okay, 20c1 into 0.1 power 1 into 0.9 power 20 minus 1 plus 20c2 0.1 power 2 into 0.9 power 20 minus 2. Simplify all this term one by one. We'll get, so when you simplify, this comes as a 0.323. After subtracting from 1 all these three components, it comes as a 0.323. Now look at the question. We have 1,000 such samples. With that at least 3 defective probability, we got it as 0.323. Now for this 1,000 samples, at least 3 defectives if you want to calculate, you need to multiply the 1,000 with the probability value 0.323. So therefore for 1,000 samples with that probability, you will get 1,000 into 0.323 elements of the products will be defective. It comes as 323. So out of 1,000, 323 will have at least 3 defective satisfaction case. And that's what about the